Hello students, in this lecture of R programming, we will be discussing about matrices. So in this session, we will be talking about what are matrices, concept of matrices, creating matrices in R, naming dimensions, column names, row names, matrix operations, indexing an element from a matrix, slicing a matrix, matrix operation in R, visualizing with matplot, subsetting, visualizing subsets, and creating a factor in R. So students, first of all, what are matrices? We have to understand one thing, that matrices are the R objects in which elements are arranged in 2 dimensions, which is a rectangular layout. Which means that when we are storing data in matrices, we are storing the data in the form of grid of rows and columns, which finally form a rectangular layout. So they contain elements of the same atomic type. Atomic means of the same data type. Though we can create a matrix containing only characters or only logical values, they are not much of use. Why? Because we store matrices normally to use numeric values. We use matrices containing numeric elements and can be used in mathematical calculations further. So students, how can we go about this facility in R and create good matrices and compute on the data? So the command is called as matrix followed by parenthesis. So this is a function, we call it a matrix function, which is an inbuilt function, and it will create an object, or you can say the data will be created, which will be of data type matrix. Basic syntax for creating a matrix in R is matrix within brackets data, comma, n rows, which stands for number of rows, comma, n column, which stands for number of columns, comma, by row, which decides whether the data will be stored row by row or column by column, and dimension names, which give the name of the dimensions. So following is the description of the parameters used, and let's understand the description. Data is the input vector, which becomes the data element of the matrix. So mainly data is the main variable, or we can say the main parameter of a matrix, which becomes the input vector. Next we have the n row, which is the number of rows to be created. Next is the n column, which is the number of columns to be created. Now by row is a logical tree. By row, if true, then the input vector elements are arranged by rows, and if false, it means that the input vector elements will be arranged by columns. Then we have the dim names, and it is assigned to the rows and columns. So let's take one example and understand the concept of matrix. Naming dimensions, column names, and row names. The first line is elements are arranged sequentially by row. Then M is assigned a matrix with the help of matrix function, where within the matrix we are passing a vector with the help of C function. The vector is values from 3 to 14. N row equals to 4, which means there are 4 rows in the matrix. By row is true, which means that the data will be stored row by row. And then we are printing M. So we are printing the matrix on the screen. Elements are arranged sequentially by column. So here, if we are storing the data sequentially by column, we store n equals to matrix. Within the matrix, we pass C, which is the vector, 3 by 14, comma, n row equals to 4, which means 4 rows are there, and now the by row is equal to false. This means that we are storing the data column by column. And then finally, print n. So with the help of print command, we are directly printing the entire matrix. Next command, which is defining the column names and row names. Let's understand how we can do that. So as we have seen, row names is the variable name where we are storing the value row 1, row 2, row 3 and row 4 with the help of C function. And likewise, column name is the name of the variable where we are storing the column headings, column 1, 2 and 3 with the help of columns. And these three headers are stored in column. Then is the P, where we are assigning it a matrix, and then finally we are listing it and we are printing P. So that is how we have created a matrix and we have printed P. And you can see the output. So students, indexing an element from a matrix. We will see the meaning of indexing an element from a matrix. Now we all know that the matrix are comprising of rows and columns, which means that every cell is defined by a row number and a column number. So basically, when I have to access an element of a matrix, I have to give the row number and the column number. So in this example, we can see that we have defined the column and row names. Row names is C, row 1, row 2, row 3 and row 4. So row names are what? Row names are the name of the rows and column names are the name of the headers. And we have created a matrix which is created with matrix function and it is stored in P variable. You can see over here that the P variable is having matrix of size 3 by 14 with n rows, which is 4, by row is 2, and dimension name is equal to list of row names and column names. And we have given the row names and column names as row 1, row 2, row 3 and row 4, and column name as column 1, column 2 and column 3. Now we are accessing the element at third column and first row. So how we will go about it? So students, it has become very easy. As you can see in the code, with the print, we are passing the matrix P, and within the P, there is a square bracket, and in the square bracket, we are passing 1, 3, which means first row and third column. So first row and third column. Likewise, suppose I want to print fourth row, second column element. What will I do? Print P, fourth row and second column. Now, likewise, suppose I want to access only the second row. So what will I do? I will write print P and only the second row, comma, no column number, which means access only the second row. And likewise, only the third column. So there what I will do, I will write print P and square brackets, comma, 3, which means only the third column. So that is how I'm accessing either a particular column of the entire matrix or a particular row of the entire matrix, or maybe a particular element of the matrix. So this is the concept of index, where I am trying to find out a particular value in the matrix with the help of rows and columns, and I'm giving row, comma, column, and I'm printing it on the matrix computation. Now, when we are doing matrix, definitely why we are storing numbers in the matrix? We have to do certain kind of computations. So various mathematical operations are performed on the matrices using the R operators. The result of the operation is also a matrix. The dimensions, that is the number of rows and columns, should be same for the matrices involved in the operation. So let's have a look at how matrix addition can be done. So here is the case of a matrix where we can see that we have to create 2 by 3 matrices. Now when I say 2 by 3 matrices, it means 2 rows and 3 columns. So you can see in the code, matrix 1 is assigned values 3, 9, -1, 4, 2 and 6 with the help of matrix function. So we have passed the vector with the help of C function, where there are values which are passed, and n row is equal to 2. N row equals to 2 means there will be 2 rows. So automatically this data will be divided into 2 rows and it will be stored. And then finally we are printing matrix 1. So this is about matrix 1. Second, we have matrix 2, where again we are creating a matrix with the help of C function, C vector function, and creating a vector with values 2, 0, 9, 3 and 4. And there we have rows equals to 2. And then we are having print command where we are printing the matrix 2. Next, we see what is there in adding the matrices. So students, in parallel, you can see the output also, that the two matrices which we have passed as values are printed on the screen. You can see that the data is stored row by row, where we can see 5, 2, 0, 9, 3, 4, where row is equal to 2. So you can see over here that the matrix has been printed. Like that, we are storing the value. So we can see the first matrix also, the values are 3, 9, -1, -4, -1, 4, and 2, 6. So that is how the matrix are printed. Now we are adding the matrices. Now when we are adding the two matrices, which is matrix 1 and matrix 2, keep this in mind that the first element of first row, first column will be added to the first row, first column of the second matrix. And like that, first row, second column is added to the first row, second column of the second matrix. And that is corresponding values of both the matrices at the location are added and stored into the third variable. So you can see over here that result is written matrix 1 plus matrix 2. So you can see how easy it becomes to add two matrices where there is no need to keep a track of index. The only criteria is that the two matrices has to be of the same size. And then we print cat, result of addition, and we print result. Likewise, we can see subtract the matrices, and there we are storing matrix 1 minus matrix 2 into the result variable. And there we are writing cat, result of subtraction, print result. And there we are printing the result of subtraction. So that is how we can do addition and subtraction on the matrix. Next, we have matrix multiplication and division. So students, we have seen matrix multiplication and division in mathematics, and now we will see this how we can do this in R programming. As you can see in the code over here, again we have created two matrices of size 2 by 3, and their names are matrix 1 and matrix 2. So you can see over here matrix 1 is here, which is having a value 3, 9, -1, 4, 2, and 6, and n rows are 2. So you can see the values over here. So 3, 9, -1, 4. So you can see that when the by row is not true, which means the data is stored column by column. So you can see over here, if by row is not true, in that case, the data is stored column by column, and we have the values as 3 and 9 in the first column of the first matrix, -1 and 4 in the second column, and 2 and 6 in the third column. And then we have the second matrix again in the same fashion, column by column the data is stored. Next, we have multiply the matrices. Here we are multiplying matrix 1 into matrix 2, and the result of the multiplication is stored in the result matrix, and finally the result is displayed on the screen. So you can see the result of multiplication over here. Then we have the divide operation, where again what we are doing, we are dividing my matrix 1 divided by matrix 2, and the result is printed on the screen, which you can see the result of division is also there. So students, we have seen the indexing of matrix, and we have also seen the operations on the matrix. Now we will see slicing a matrix in R. You will ask, what is slicing of a matrix in R? So basically slicing means that suppose I want to take a particular section of data, or maybe a particular set of data from the entire matrix, then I call it slicing. So the same example, if we see the case, here we have seen that there are rows and columns, and row name is row 1, row 2, row 3, and row 4, and column names are column 1, column 2, and column 3. So we have to create a matrix, and we will write here matrix C 3 to 14, n rows is 4, and by row is 2. So here if we want to store the data row by row, we have entered true, equated true to by row, and then we are giving the dimension name equals to list row name and column names. Now we start accessing the elements of third column and first row. So what we are doing over here, we are doing slicing. We are finding out a particular slice, and how we have taken the value from the location first row and third column. Likewise, X is the element at second column and fourth row. So we are printing P square brackets 4, 2. If I want to take the second row, again what I am doing, P then square brackets 2, nothing. So the entire second row is taken out. And likewise, if suppose I want the third column, what I am doing, I am taking print function, within that calling the matrix name P, and in the P I am passing no value, 3, which means the entire third column will be printed on the screen. So this is how I am slicing a matrix and printing it on the screen with the help of index.